In this video, we're looking at a single diverging lens with a focal length of 12 centimeters, and actually I should call that negative 12 centimeters, because in the thin lens equation, we're going to have to call it negative. And we have an object sitting at a distance of 8 centimeters from this thing, so that's inside the focal length. And we're asked to produce a ray diagram with all three principal rays to approximate the image location and the magnification. And then we're going to find the real answers by using the thin lens equation and the magnification equation. So let's get our principal rays into this thing. First, a ray leaving the head of that object through the center of the lens is undeflected. Next, a ray leaving parallel to the axis for the problem will be bent away from the axis such that it appears that it's coming from the near side focus. So that's what it looks like, where I've used a dashed line to indicate a place where there's not actually physically a light ray, but that's the direction it's coming from. And then finally, a ray headed toward the opposite focus. So again, a dashed line where the light ray is not actually physically at, but it was aiming towards the opposite focus. That's going to be refracted parallel to the axis. Now on the right-hand side of this lens, I see three diverging rays. So where the image is formed is where we perceive the convergence of these three rays. So there should be a common point that they're all coming from. So I only have to trace back on one of these because the others already have traces back in the diagram. And I see that all three of these diverging rays have a common point of origin, and that's where we're going to see the image form. And that's an upright image, and I can see that it's shorter than the original object. Now I get into my approximations. So what's the approximate image distance? In this diagram, I can see that every grid space counts for 2 centimeters because the original object was 4 spaces left of the lens. That was an object distance of 8 centimeters. The foci have a distance of 12 centimeters from the lens. That was 6 spaces in the diagram. So where's our image formed? It's a little more than 2 spaces. So it looks like a little bit less than 5 centimeters. And because that's on the near side of the lens, we call that negative. I'm going to go ahead and call this negative 4.8. Then for the magnification, my original height for the object was 2 grid spaces. My final height is a little more than 1 grid space. I'll call it maybe 1.2. So my magnification would be the factor this thing shrank by. So 1.2 divided by 2. And that gives me 0.6. And that counts as positive because the image is upright. Now to get the real answers, I'll use the thin lens equation and the magnification equation. So I have 1 over di plus 1 over do is 1 over f. Remember, f counts as negative for a diverging lens. So I have 1 over di is equal to 1 over f, so negative 1 over 12, minus 1 over do. That was a 1 over 8. So I take care of the right-hand side in my calculator, and then I take the reciprocal of the result to find di. And I end up with an image distance of exactly negative 4.8 centimeters. And you'll have to take my word for this, or if you don't believe me, watch my other thin lens videos. I don't cheat on these. When I was approximating this, I was actually just using the ray diagram. And as I was guessing what number to write down on that, I just got lucky this time and got exactly the right answer. Now we'll wrap things up with the magnification. That's negative di over do. The minus sign is there just so that we can count an upright image as positive and an inverted image as negative. So when I plug in my image distance of negative 4.8 centimeters, then my object distance of 8, the double negative, it's going to make the answer come out positive, and my 4.8 over 8 comes out to exactly 0.6. And we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.